Now we are looking for example 5.4.2. In here we are trying to solve when we have the difference between two sample means. So from the contents, if you read, probably you already know that if the two population distribution that is if they are following the normal distribution with some means and standard deviations, then the difference between two means of the two population should follow mu1 minus mu2, and variance with this like this. Okay, so that is from the chapter page 149. Using this theorem, I just trying to solve the example 5.4.2. Yeah, I mean, in here same thing. The x variable, finding x variable you are interested in is the most important job. Okay, if in here the x variable should be a certain type of client, the average length of a home visit by a public health nurse. Okay, and then if we divide them to different group, like x1 is first type of client's time length, and x2 is the second type of client's time length, and then from the some information in the question that x1 follows, we don't know that is normal or not, but that mean is 45 and the standard deviation is 15, and then x2 is follow here same thing. I mean, we don't know what the distribution that had, but mean is 30 and the standard deviation is 20. And he or she collected the data from the first type of clients 35 and second type clients is 40. And then the question in here is, what is the probability that the average length of home visit will differ between the two groups by 20 or more minutes? So the question in here is x1 bar, that is the sample mean of the x bar, I mean the first group, minus the sample mean of the second group is bigger than 20. That is the probability of that one is we are interested in. So using that theory in the 149, a new variable is a difference x1 minus x2, right? That's a new variable actually. Then the difference, that new variable is if these two variables following is normally distributed, then that difference also normally distributed, and with mu1 minus mu2 as a mean of that difference, and then standard deviation looks like that. Okay, so if we just draw that as a graph in here, that difference has mean equal 15 because 45 minus 30 is 15, right? And the standard deviation is, which I just put that numbers input in the formula, so that will give you 16.4286. So that is the difference normally distributed. Okay, that is the difference of the mean, like mean of the difference. So that follows 15, and mean is 15 and the standard deviation is 4.05 from here. And then we want to know the probability of z, I mean the difference is bigger than 20 or what? What is the probability that in here? Okay, that is the question. So if we have to do that, then we have to find the z-score in here. So just put that in here. The 20, that is the actual number we have in here, and the minus mean of the d difference, and divide by this. I mean divided by the standard deviation of that one. So actually that one is a variance. So I have to square root of that, and we got this 5 over 4.0532, and that is 1.23. So that is, if we just draw the graph, that is a z graph. So we want to know if that distribution, that means the difference, then the mean of the difference is bigger than 20. That point is 1.23. So we want to know this area, the probability of this area. That one is 0.1093. So the target probability we want to know, that is 0.1093.